Okay, I got an idea. I'm gonna make a video sharing this idea that I have on uh, transmitting resonance or mechanical vibrating energy. And what I want to do to explain this is first I'm going to start with kind of like how transformers work and Slayer exciters and such. Is you have a coil that you connect to a DC source, and you turn that DC source on and off, and it makes for an expanding and collapsing magnetic field as the coil turns on and off, and that makes an alternating current in this coil. Tesla coils work like this, where you have a really large primary coil and a very long, thin wire secondary coil. Slayer exciters are used with this type of transformer, so are a lot of Tesla coils. But when you use this is only a transmission of the electrical energy by a expanding and collapsing magnetic field. So it's not good for transmitting mechanical force or motor force. And what's good at transferring magnetic power into motor force is you have to actually physically move the magnet. Like, this is just a magnetic field expanding and collapsing. The magnetic field isn't actually moving. Um, this is how most mechanical force is generated through generators by a magnet physically moving through a coil one way and another way, making an alternating current. And this is how most electric motors get their mechanical force. And after going over that, I want to explain the idea of resonance when you have a very heavy rod that's just hanging freely vertically, and you strike it up and down. It tends to vibrate very efficiently, and when it's vibrating up, and it's vibrating down. When a rod vibrates, when something vibrates, it either goes side to side really fast, or it goes up and down really fast. And in this case, we're going to be going up and down really fast. And this idea is going to have to use synchronous and sophisticated computers to kind of operate this. But what the idea is that you have a very heavy rod that's vibrating up and vibrating down, and you have a coil wrapped around it. And what you do with the synchronous computers is you turn the coil on and off as it goes up and down. And you would start by turning it on, and the rod would start to vibrate up. But then when it goes up, you would turn the coil off and then on again, and then it would vibrate down. And then you would turn it on and then off. You turn it on, and then it would go vibrate up, and then you would turn it off and then on again, and it would vibrate down. Off, on, vibrate up, off, on, vibrate down. So you're turning it on and off as it moves. So you turn it on, it moves, off, on, it moves, off, on, it moves, off. So you would need a computer to know how many times this rod is vibrating up and down, and you would need it to be able to turn the coils on even faster. You would need to go up, coil, like the coil's on, it moves, off, then on, it moves, then off, then on, then it moves, and off. So you're expanding and collapsing the magnetic field, but at the same time, when the magnetic field is all the way expanded, the rod vibrates down, and then you turn it on and off again. And then you would have receiving rods that would turn on only during this thing's vibration down motion. Like you would have some sort of it would be like a coil around a receiving rod, and every time this coil turns on and then moves down, you would have another receiving rod coil turn on, and it would receive that downward force. But then you would turn it off when it vibrates up, and then turn it back on again when it vibrates down. So you would be transferring just the magnetic field and the downward motion. And you could do the total opposite with the upward motion. You have a receiving rod that turns on whenever it's vibrating up. And you would need computers to, synchronize all this. I mean, it would be very complicated, but with, transistors and semiconductors that we have today, it would be really easy to kind of grasp a computer that would be able to turn something on and off this quickly, because that's what, really fast computer processors do. There's just a bunch of transistors that turn on and off really, really fast. So if we can have a rod that a computer is following its vibrations up and down, and it turns the coil on and off in sync with its up and downward motion, and I think that would be a way of basically transmitting electrically a Slayer exciter signal or a wireless power signal. But in order to get mechanical force, you actually need physical movement to be transmitted. So when you're turning the electric coil on, you're getting movement in the magnetic field, up and down, the vibrating up and down movement. And you're using receiving coils to capture just the downward movement or just the upward movement of a really heavy vibrating rod. And I really believe that this can be done electrically, but it would take a lot of setup. You'd have to get all the coils ready, and you would need the computers to be able to monitor, measure, and be able to turn the switches on and off at the appropriate times in order for this idea to work. It would have to be really in sync. All these coils, the receiving rods and all these coils would really have to be in sync with each other. But there's nothing here that isn't possible. It's really a basic idea of transferring mechanical force with vibrations, but you're only going to be receiving the downward force or the upward force specifically. Because when something's vibrating up and down, it's pushing its weight up, and then it's pushing its weight down, but it doesn't go anywhere. So it vibrates up and down or in place really, really fast. But if you can have a way of capturing just the downward force, then it's like transmitting almost like a constant, really fast tapping downward force kind of a thing. Anyway, you probably get the idea, so let's go ahead and we'll stop it here. And yeah, I just wanted to share this idea that I came up with kind of a couple years back. Alright, thanks for watching.